key belief around that, like blockchains and other decentralized infrastructure were going to be able to help us build infrastructure that can power the next generation of the internet and can basically create public goods that are not operated by governments or companies. Public goods like the internet itself, things that are globally accessible and fundamentally effectively human rights. We started Connext because we wanted to bring blockchains to the broader consumer public, which at the time, this is something that like people hadn't even begun to think about. I think ETH price was like $20, $30 at the time. This was like really, really very, very early. And we started to build, we started to like look into like infrastructure in the space. And the key thesis was, how can we scale this to 1 billion users? How can we bring Ethereum to the like majority of the world's population, or at least like the early majority of the world's population? Now, pretty quickly, that led us to scalability research, because even at the time, it was pretty obvious that Ethereum wasn't going to scale. And we became one of the first L2 R&D teams. We actually built the first layer 2 on Ethereum. It was a state channel network. So state channels are a type of scalability solution designed for payments. It was a state channel network that was built in partnership with a company called SpankChain to do adult micropayments, tipping for adult Camstars. It was really cool. It was also the only project in the ecosystem at the time that had any real traction. So it was actually pretty interesting. And we ended up working on like scalability research alongside a lot of the other L2 teams, a lot of the teams whose names you'll recognize today. So like the Plasma group, originally the Omisego team that became the Plasma group team that eventually became Optimism, the early researchers that eventually became Arbitrum, folks from places like Polygon, early. I mean, at the time it was called Matic, but eventually became Polygon. And started to try to understand how Ethereum would scale. And in about 2020, we kind of realized that there was the whole ecosystem sort of realized that rollups were going to be the future of scalability. And we saw that there was this very interesting opportunity to do communication between rollups. On our side, there were too many high quality teams building too many really, really well-respected projects with backed by very significant investors that, at least from our perspective, it seemed very unlikely that there would be one winning team. And so in 2020, we built this POC called Spacefold, which is the first ever Arbitrum to Optimism bridge. It's actually the first ever cross-chain, trust-minimized cross-chain transfer bridge on testnet that was specifically designed for things like rollups. And this was, of course, before any of the rollups had really gone live, so we were definitely quite early. But we wanted to POC this idea, and it actually ended up becoming extremely well talked about. Because this is something that a lot of folks hadn't really even begun to think about yet. The communication, or the sort of fragmentation of liquidity and the fragmentation of user experience as a result of moving to many different rollups. It was still really early. We didn't really know exactly what the right market was, or if this was even something that was worth pursuing. So in 2020, by the end of 2020, we had kind of built this early implementation of scalability solution that was targeted at payments, but also could do cross-chain transfers, called Vector. And that was when things became really interesting. So Vector, so we as a team have always been very developer facing. Our focus has always been, let's try to help build picks and shovels that devs can use to build awesome applications. We never meant to build a consumer UI. We never meant to build a consumer bridge. And yet in early 2021, once we went live with Vector, we started to work with projects in the ecosystem, especially in the Binance Smart Chain, Polygon, and xDAO ecosystems. And I think some of the earlier folks who may be on this community call may actually remember the early days when those three chains were actually extremely heavily used, and Connext was the primary mechanism to get between them, or at least one of the primary mechanisms. And it was around that time that we had a community project, or a DAO that we were collaborating with called OneHive, built a POC, which became xPollinate. xPollinate was a application that was built on top of Connext. It ended up being the main application built on top of Connext for quite a while, because while we were really interested in empowering developers to build more interesting, complex cross-chain applications, the core problem of just how do I get my token from chain A to chain B hadn't yet been solved. And xPollinate ended up growing incredibly quickly. We were definitely not prepared for that. I think the team was like 5 people at the time. And so we were trying to, I think everybody was basically spending like 18 hours a day providing support and trying to fix the infrastructure as it grew. And it wasn't until later that year that we were able to like ship NXTP, which ended up being like a much more stable implementation of the network, where the team wasn't having to like continuously spend all of our time like fixing it in production. Now, of course, there's definitely still issues with NXTP. A part of the complexity and the difficulty of building distributed systems is that you don't always know exactly how they'll behave until they're live. And some of the assumptions that we had around like the liveness and stability of routers, things like that, were actually turned out to be incorrect. And so it's taken almost a year longer than after we released NXTP to get to the point where we now have an upgrade that is ready to go, that solves some of the core problems that NXTP introduced, and also improves on the system to allow for generalized communication. So yeah, that's kind of a brief history of Connext. We definitely want to tell more about this story at some point in the future. But for now, I'll kind of hand it off. I believe the next things that we'll be chatting about are, actually, I'll keep kind of touching on this for a minute. So one of the key things that we realized is that there's a few like key principles that we realized over the course of building over the last few years that have helped shape the way that Connext should be built as a system. And one of the key, like some of the key realizations are that this whole space moves so quickly, and research in the space happens so quickly, that you can't necessarily make any bets on a singular type of like infrastructure or security model. These things change very rapidly, and even right now with bridging, right, we were working with Nomad, who's pioneering the optimistic bridging mechanism. We've written extensively about optimistic bridging, and we still believe optimistic bridging is the best system, like best kind of bridge available today. But there are already teams working on like ZK bridges, which can actually provide even better security. And of course, like it'll take a lot of work to get there, in the same way that it's taking work to get to ZK rollups. But we like one of the core things that we realized was, as a project that cares a lot about security, that cares a lot about user trust minimization and decentralization, we can't make a bet on any one singular type of infrastructure. And so the things that we've kind of realized are, we want to focus on security. This is something that we've always cared about, and it's something that like is a core part of our DNA as people who have spent the last 5 years working on L2s. But even beyond that, we want to focus on modularity and extensibility. And what that means is, and future proofing. What that means is basically making it so the system you can plug in better mechanisms into the system in the future as they get researched and developed, and do that in a way where, unlike with what's happening right now, where we're upgrading from NXTP to Amarok, and that upgrade has taken a very, very long period of time, and in the meantime your user experience is changing. Like the user experience currently with NXTP is going to be different than the one with Amarok, and as a result of that user experience changing, like the integrations that people do will have to change, users' habits will have to change, documentation will have to change. Instead of trying to follow that kind of upgrade path, what we realized was, let's keep the interfaces, let's keep the experience of using Connext exactly the same as it always is, and make the rest of the system very modular. And what that means is making it possible for us to switch out the components within the network itself, or eventually for the DAO to switch out the components within the network for itself, in order to make sure that we can keep up with the best technology that is available at the time. The last two kind of key values that we've also discovered are composability. So making sure that Connext itself is something that can be very, very, very easily integrated into. We see Connext as a core primitive. So we think that the future of like this ecosystem is applications that will live on multiple chains simultaneously. Right? It doesn't really make sense for you as a user to interact with like a bridge, or even Urine sitting on one chain when you might have funds on another chain. Like the concept, the idea that you need to even know what chain you're on is actually very boomery. And the way that we beat that is just by having seamless composability across chains, seamless composability into Connext, and then also composability between applications that are connected by Connext. And so that's a core piece of what has gone into our thinking around Amarok, and something that we've been striving to improve consistently over the course of the last year. And then lastly, this is kind of fits into that. The other side of that is, aside from the composability, across chains, also the ease of implementation for a developer that wants to integrate Connext. So making the experience of building on top of Connext as good as it possibly can be. These are the kind of high-level values and design principles that we've kind of honed in on as being extremely important to us. And then these exact design principles have informed the upgrades or the changes that are happening as part of Amarok.
Cool. So there's a lot of things that we're excited about Amarok. A lot of them are the technical architecture that, well, I mean, I guess that's mostly me, but a lot of them are the technical architecture things that Arjun just went over, but there's a lot of other really cool features too. One is one-click UX. So something that kind of sucks about NXTP right now is that it consists of 4 transactions. The last one requires the user to sign a secret and reveal that secret. That isn't the best because users often go like fire off the bridging transaction and then they leave, and then we kind of have to remind them that they have to sign something. And, you know, in general, the fewer clicks you can have in your system, the better. It's just a nicer feel. Like everybody appreciates when somebody screenshots or screen records a meme or whatever before they send it on their phone instead of sending them the link. Same principle applies to bridging. Then we also, it's a much better user experience for LPs. Right now, LPs provide liquidity on the destination chain and they accept liquidity on an origin chain, which means if in times of like high demand, all of your useful liquidity is frequently getting drained and you're going to have to figure out a way to rebalance that. The other great thing is this really only includes 2 transactions, a start on the origin chain and then a finish on the destination chain. So it should be faster, hopefully, and cheaper as well. And the other thing that we're most excited about is we allow for arbitrary message passing. That currently isn't available in our NXTP v0, which means that any action that you take has to be fully collateralized. And what I mean by that is it's not possible to send information that you can't strictly assign a financial value to, because the system works by both people putting up funds. With Amarok, we'll be able to have a much more expressive system, and people will be able to build apps that are truly cross-chain native. The signature helps there, or removing the signature helps there as well, because now we can more easily support direct smart contract integrations that obviously can't sign things in the same way. So going into kind of how it works, Arjun mentioned this modular architecture. I'm going to talk about each of the layers that we see from bottom up, because I think that's a little bit easier to understand. So basically you have the transport layer, and the transport layer just defines, okay, how do I get data from A to B? Right now we've built a messaging system that uses other people's transport layer. And what I mean by that is we use the default roll-up bridges in kind of a hub and spoke model to pass data through from origin to hub to the destination spoke. This is great because it allows us to use the most secure mechanisms available in any given environment. The next level is verification. Verification just means, okay, how can I evaluate the veracity of the messages that I've now gotten from point A to point B? What's really cool, What's really cool about how we've done this is we're able to plug in any type of transport layer with any type of security guarantees, trust minimization guarantees, and normalize it all to a baseline security that we're comfortable with. So by default, all the verification will be optimistic, which again, we believe is the most secure bridging implementation available right now. But in the future, you can have different types of verification depending on the path that you're going through. So imagine that I'm going from Ethereum to IBC, or like Optimism to IBC. On the first leg of that, it may be optimistic, but once I get into Cosmos, I can just use the IBC verification. And then you have the execution layer, and the execution layer defines how the message will be put into the transport and verification layer. So it packs the messages, handles all of that. And then on top, you have the liquidity layer. And the liquidity layer is really responsible for providing a super easy to use interface for developers and also managing all of the asset complexity. So in bridging, like you guys may have gotten some assets that you really have no use for. And ideally, your bridging system has a liquidity layer that handles all of that for you. So the only time you get some shares in an LP pool that you didn't know you were actually LPing for when you're bridging is when you specifically request it.
So good counterexamples of this are things like multi-chain, where sometimes depending on what liquidity is available, you might get any assets. And that's kind of unintuitive, right? As a user, you want to be able to get the most widely adopted asset on a given chain. The way that you do that is by having pools of liquidity available and making sure that you can swap into those pools of liquidity for that asset. So you get Polygon POS USDC on Polygon instead of any USDC, or in our case, Next USDC. And I think that it's ends up becoming an extremely unfortunate user experience when users have many different fragmented types of assets. But of course, it's also sometimes necessary, right? On a chain where no canonical asset exists, it is needed to mint something.
Yep, and the great thing about this is the only layer that users should ever need to know about, regardless of what chain they're on, is that liquidity layer. So there's a lot going on under the hood, but really the way it's presented is pretty simple and intuitive. So that's great, layers are cool, but how does it work for a user in the life cycle of a transaction? So first, if you're going from Polygon to Optimism, you'll send in your POS USDC to the liquidity layer with a function called xCall. We'll get into that function later. It's pretty cool. And once you have sent in that asset, it swaps into an asset that the bridge controls. So this is our Next USDC. From there, we can burn it. That's why we have those assets. It's just a means of accounting in most cases where there's an adopted asset. So we swap into Next DAI on the first leg and burn it. And then we craft a message that we can pass through to the Optimism. How that message flows through Optimism is it's sent through the Optimism AMB directly to our contracts on Ethereum. Our contracts on Ethereum take the messages from all of the connected spokes and push them back out to the destination. So this is really cool because it uses, again, the AMBs that are then the most secure way to get in and out of these isolated systems. From there, the Optimism AMB will push the data through to Optimism, where the message is ready to be executed and acted upon. What I mean by that is more Next assets are minted to replace the ones that were burned when you entered the system, and then they're swapped for DAI and an AMM on the Optimism chain and sent to the user.
The cool thing about this is that experience looks exactly the same no matter what ecosystem you're in. So we use the rollup AMBs, Polygon Bridge, etc. Within the Ethereum ecosystem, but then this extends out to other places as well. So the system runs the exact same way on top of, if you're in Cosmos and building on top of Cosmos chains, it would run the exact same way on top of IBC. In the Polkadot ecosystem, it would run the same way on top of XAP. Eventually, when you have ZK Sync builds their layer 3 chains where you have application specific ZK rollups building on top of ZK Sync that are posting data to the shared ZK Sync DA layer. This will run exactly the same way on top of that DA layer. And that's kind of what we mean by making this a pluggable modular framework, is we want to make sure that no matter where you are as a developer and user, the experience of using Connext is the same. It shouldn't matter the difference between some random Cosmos chain and ZK Sync shouldn't matter to a user. It just shouldn't.
Not only that, but having all of this be pluggable, especially at the messaging layer, really allows us to use the best-in-class tools for any given ecosystem. you're just not going to really get better than IBC on Cosmos. You're just not. And so whatever you build that should be like kind of this amorphous layer between all of these environments has to be able to use whatever is best for a given path. Oh, Rahul, you're muted.
Oh, holy crap. Sorry, guys. Hey, everyone. I'm Rahul. I'm the other co-founder of Connext. I'm on the tech side, tech lead. So what I want to talk to you guys about is kind of like how to build on top of what these guys have been talking about. Like, you know, we built all this really cool infrastructure, all this awesome stuff, but like where it really gets sort of comes into like people's viewpoint is at this developer interface. So just to like piggyback on top of what Arjun said, like Connext, we have never really like wanted to be like an app building company. We've never wanted to like build and own our own UIs, our own dApps. Like we think there's other people that are like great at doing that. And what we want to do is we want to provide the tools and the infrastructure for people to be able to like make use of this technology. So while we abstract all this like incredible stuff under the hood, what we put on top is a very simple primitive. So this is really one thing that developers have to learn. The only thing that developers have to learn to use Connext within their own xApps, what we call the cross-chain apps, is this function called xCall. So this is supposed to be equivalent to, in Solidity, you have a function called call, which can be used to pass value and data to any smart contract, any function on any smart contract. So what we wanted to do is extend that same exact system into a cross-chain primitive called xCall. So the function xCall, as you can see here, it only takes a few different parameters, things like, you know, where you're sending it to, what asset you're using, what data you're using, and then some other like random little parameters like slippage and delegate and stuff. But essentially what it is, it's a very simple way to kind of bundle up all the complexity of making a cross-chain transaction into a very simple call. And, you know, like this diagram on the top left shows, you call your xCall from your xApp into Connext. Connext takes care of all this like crazy bridging, AMB, you know, routing protocol type stuff. Will call some function on some chain. And then the cool part is it can also get you that data back into your xApp. So what you can do is you can do this whole process where you call into an app. You can possibly also send funds. You can do whatever you want to do, and then you can return the data back. So yeah, next slide. So, you know, what we think xApps are the future. So we think all DeFi pretty much is going to move to cross-chain. Like DeFi is pretty much already multi-chain. Every app on DeFi has like multiple chains. You know, you can always do this drop down. You can choose multiple chains. So then, you know, we think this is kind of like inefficient and not the best way to do it. Like users are confused by this. Users have to go to these bridge UIs and do all this stupid stuff. But like really that's a bunch of extra steps when the app itself should be containing all this like complexity and abstracting that to the user completely. So this is what we think is the future. And with the Connext tooling, we can provide this like layer of abstraction to make this possible. So some things that you can build with this. Cross-chain dexes, any-to-any swaps. Already people like Lee Finance are building this type of stuff. So this is kind of like the easiest sort of xApp that we think has been like kind of come to the point of maturity now. Cross-chain lending, this is a little harder. Deposit on chain A, borrow on chain B. I know there's protocols we're working with that are doing this as well. This will be very cool because, you know, you can manage liquidity on multiple chains and kind of like, it doesn't matter which chain you deposit in, you can borrow on another chain. Yield aggregators, like Arjun alluded to, you can basically rebalance your vaults across different chains, harvest the best yield, automate this whole system so that you're not the one bridging your funds back and forth. The app is doing this for you. Cross-chain NFTs, I know a lot of people have been interested in this, and we've gotten some questions about this as well. Basically, what a cross-chain NFT is it uses the Connext infrastructure to be held in escrow on one chain, which is the chain where it is originating on, and then the bridge will be able to mint a representation of that NFT on any other chain. So, you know, we'll provide the tooling to do that, as well as the tooling to marketplaces and NFT apps to actually be able to like understand the the different types of the mechanism of this and understand how to basically display and use these NFTs. So, you can use NFTs, these cross-chain NFTs for cool things, like you can mint it on an L2, move it to an L1 to be more secure. You can basically provide it as collateral on new domains, all this other kind of stuff that you can do just because you have the optionality to use whatever chain you want for whatever purpose you want. Cross-chain infrastructure. So, there is a bunch of infrastructure that already exists. But, if you can expand this out into multiple chains, we think you can basically build some more tooling that will make the cross-chain world a better, something that is able to be realized. Like right now, there's a lot of base level infrastructure and tooling that it just isn't there. Like DAO tooling, for example. I think there's some examples of cross-chain DAOs, even things like Curve are trying to innovate in this area, but because they don't have a really solid framework for sending messages around, they're not able to govern their protocol cross chains. They still only have all their gauges on mainnet. But what we want to do is we want to make the process of being able to use DAO tooling whatever chain you're on, and use make a multi-chain app truly into a cross-chain app. That's the difference between multi-chain and cross-chain. Multi-chain means basically things are copy-pasted on each chain. Cross-chain means they are actually interacting with each other in a way where governance maybe defines and controls all these different systems as one system. So DAO tooling is something that we're really excited about and working on. Cross-chain oracles as well. Oracles have this problem where they need liquidity to work well. So if your liquidity is jointed across many chains, you're going to basically lose the fidelity of your oracle and you're going to be susceptible to oracle attacks. But if you can pull the prices from a chain where you have the liquidity, you can actually make this all work well. Cross-chain tools like wallets, identity, that's kind of base level consumer facing infrastructure that can be taken cross-chain and basically made in a way where it doesn't have to be copy pasted from chain to chain. It can actually exist on the chain it's supposed to exist on and then be ported over to other chains through bridging mechanisms. Just to jump in a little bit about communication and how communication works in a cross-chain world. I'll try to stay pretty high level with this. Basically, when you do things on the internet, you are interacting with asynchronous remote resources. So if you basically go to a site like Google or something like that, you're going to be connected to some server somewhere. It's going to return some data at some point in the future. And that's just basically how the world works. That's how computers work. That's how programming languages work. That's how everything on the internet has been designed so far. On a blockchain, this is very different. So you have your MetaMask wallet, for example, you send a transaction to the blockchain, and then you either know if it works, you get a response, or as you guys may have seen in Explorer, it just reverts, which means it didn't work. So nothing happens. Either it works or it doesn't work. That's basically what the synchronicity and asynchronicity is. In the first example, if it doesn't work, then something happens somewhere else that needs to be handled properly on the callback mechanism of it. So let's move on. Basically, what we're doing at Connext, we alluded to this at the start with this whole callback pattern, is we have provided a way to have asynchronous communication within Solidity itself and within your smart contracts. So with Connext, you can send messages on an origin chain. Connext will give you the ability to execute things on the destination chain and then bring back the data to you so that you are able to handle it properly. And this is a really important paradigm that we are going to start speaking more and more about and start educating users and the wider community around this, because we think this is a really important paradigm that really is going to define the way that cross-chain apps are built. I think, there's a couple layers of complexity to building cross-chain applications right now, which is why we haven't seen a huge explosion of them and the adoption has been slower because of these kind of layers of complexity around, first of all, the interface, which we're solving with xCall. And then second of all, the asynchronous communication patterns, which we're solving with this type of callback pattern. And then, past this, providing education and tooling to help developers kind of understand how this works and how to deal with this.
Cool, thanks. Hey, I'm Alex. So I'm the product manager here at Connext. I'm super excited to talk about finally our path to launching this thing. So we've been just building through this bear market. Huge props to the Eng team that's just been grinding over the past several months. So since early August, we started refactoring to the hub and spoke A and B model that was discussed a little bit earlier. And we're really close to launching on mainnet. We're hoping to launch as early as this week in what we're calling our closed alpha. This is, as it sounded, it's a closed launch. So it's going to be internal only first for us to round out our testing, to round out some of the security of the protocol, and to do some more testing with our partner devs and really lead us up to the public launch, which is the big launch in November. So as early as, early to mid-November, we're looking to launch Amarok live finally. Users are going to be able to bridge. They're going to be able to farm yield. Developers will be able to, build against xCall, build against our SDK. And we're finally going to be live with this thing. So we're super excited to kind of sprint through the finish line here and finally announce that. And so at launch, we're going to originally support these 6 to 7 chains. This is just a starting point. We're going to start with at least USDC, and we're evaluating other stablecoins. Again, this is a starting point. We have a huge list of chains and assets we want to add. If there are chains that you want to bridge to or assets that you want us to support, please notify the team in the community Discord. We're going to listen really closely to the community on this, listen to the market, and expand really fast from here, depending on kind of what the demand tells us. But this is going to be the original launch. We're excited about all of them. ZK Sync as well. We're a little bit dependent on their timelines, but this is going to be the starting point for us on mainnet. And then, just looking forward. So we see limitless opportunities. We talked about cross-chain as a space. We're really excited about it as a category. We know that there's been a lot of adversarial activity in cross-chain, but we take a really long-term view on this stuff. As the team noted, they've been building for 5 years. We look ahead multiple years in the future. We believe in cross-chain not just because we think it's the right approach, but because users have shown demand for this over the years, time and time again. So we see our role as building a protocol that really supports this experience as best as possible. We're really focused on maximum security, trust minimization, and user experience. We think that all of that is going to give us the winning combination in the future. And we're also really focused on supporting xApps building on our protocol. So in the future, we see users being able to interact with these xApps without having to think too much about the underlying security or the complexities of the underlying blockchains, and really, just enjoy the xApps they're using with this cross-chain protocol underlaying it underneath. So looking forward, it's just a starting point again. We're going to keep expanding, and we're really excited to listen to what, the community wants and what the market wants, and kind of iterate from there.
Awesome. Thanks, Alex. Hi, guys. By way of introduction, my name is Matthew Hammond. I'm the ecosystem lead here at Connext, and just want to take a quick moment to talk about our presence at ETH India. If by any chance you will be in attendance of ETH India, the hackathon December 2nd through 4th, we'll be kicking off a day early with a hacker house in conjunction with ETH India. So if you would like to be one of the first people to kind of hack on Connext and see these use cases for yourself, we recommend that you apply. We'll provide hotel accommodations, daily meal stipends, personal mentorship with the core team, and then a set of exclusive bounties in addition to the ones that are public for ETH India. So again, there's 10 days left to apply. If you're interested, just go to connext.network/hackerhouse to apply, and we look forward to seeing you all in India. So I'll turn it back over to Arjun just to wrap up a few other items that the community's been asking about.
Matthew. So one of the main questions that we've gotten is around the contributor program. So for those of you that don't know, the contributor program is this program that we ran immediately after announcing our token, where we wanted to incentivize, basically to try to get a bunch of people within the ecosystem to start helping build Connext in different ways. So contributing to Connext by running routers on testnet as part of our early testnet process with Amarok, building infrastructure on top of Connext or helping like contribute code to Connext, creating content and marketing material around Connext, and then helping kind of facilitate and steward the community as a community leader. Where the community, the phase 1 of the community program ended a little while ago, and we do have the results now finally available. They will be distributed, I believe it's next week or so, very, very soon, through a Discord bot that is currently in development, is in the tail end of development. And then a lot of folks have also been asking, what about phase 2? So when does the next iteration of the contributor program start? So one of the things that we like didn't expect with the contributor program this time around was just, or at least in the first phase, was just how much interest there would be. So we were expecting to see a lot of signups, but not as much activity, and we were also not expecting to see just the way that like that activity played out. So we got tons and tons and tons of submissions for content, for example, and so that like that track that we had built around content creation kind of got overwhelmed. There was just like a lot to do there. There's like the judging process itself took a very long time because moderators and folks that were helping with the contributor program had to like go through each and every submission individually. In addition to that, one kind of thing that we really, really didn't expect was that our onboarding process itself would just get so incredibly strained as a result of how many applicants there were. So I think in total we had about 7,000 to 8,000 applicants. I think there were a lot more folks that we ended up talking to who were just never able to get through that process to begin with, just because the onboarding flow itself was not really designed for that many people. So those are some of the key things that we wanted to solve for phase 2, is to go back to first principles, redesign the program now that we know kind of how it will work in real life. And this time around, focus very specifically on like making sure that the onboarding flow itself is seamless. So I think work has already started on figuring out what that flow should look like and how it should work. And then on mapping out like the specific outcomes that we want to see out of this iteration. Cool. And then I guess one other piece of that's important to mention here is, of course, the DAO. So one of the key things that we had wanted to do as part of the contributor program. So the contributor program was basically designed as a way to get tokens into the hands of community members, people who were not specifically going to be like a part of the airdrop, but who were still contributing to Connext in different ways. And the goal behind all of that is to head towards seeding the initial community that will become a part of the DAO, and that will help to like foster the DAO in its earliest stages. The DAO and obviously as a result of that, the token launch are coming. This is something that like we've obviously been hinting at for a while. We've been talking about for a while. Truth be told, we actually expected to be live by now. But unfortunately, this year has been a lot more chaotic than we anticipated. And this maybe I could take a bit of an aside here to talk about like what has taken so long to get Amarok shipped, to get the token shipped, and things like that as well. So we at first announced the Amarok upgrade, I think in like March, April of this year. The upgrade came as a result of us thinking through what the limitations were with like NXTP and how we could fix them. And one of the big things was that the upgrade was like a key kind of like departure from the existing system. And so we were going to have to do re-architect the way that our system worked. The other key piece there was that it was being built now on top of an external protocol, Nomad, for messaging. And this was something that like we kind of recognized that Nomad was a team that was like a very, very strong team still in development. But we underestimated how long it would take to be able to like synchronize with them to be able to get to the point where we had something that was like stable running on top of their infrastructure. Because of course, we're two organizations that are like still in our early phases and we're both moving targets. In parallel to that, what we tried to do was we kind of forecasted ahead to what we expected the Amarok launch date would be. And we tried to, in parallel to that, announce the token and run the contributor program with the goal of having the contributor program and token launch coincide with the launch of Amarok. I think this was a mistake. I'll be completely honest, like we shouldn't have parallel processed. I think that was something that like now in hindsight, I'm realizing as a lean young organization, it's a bad idea to do multiple things in parallel. And I think that as a result of trying to parallel process, we ended up taking longer than expected to ship Amarok, and also ended up not being able to ship the token on time. Now, where are things at with the token, and where are things at with Amarok? Obviously, Amarok itself is now in the tail end of being completed. It was unfortunately further delayed as a result of the Nomad hack, and we had to kind of rethink our strategy around messaging, and basically build an entirely new messaging system and get it audited from scratch. But beyond that, the token itself is something that we, as a result of all of that happening, we kind of decided, okay, we're going to have to table the token entirely for now, and come back to it after we've actually shipped the upgrade. So when token, we don't know yet exactly, but it's something that we are currently focused extremely strongly on shipping Amarok. And at least from our perspective, once we hit a point where the team, where, the upgrade is shipped, it is stable, there is no additional input needed from the team, then we'll refocus all of our attention now towards the token and basically serialize doing the two of them rather than trying to do them in parallel. We're hoping that once that happens, maybe early next year or so. Given that it's already October, and given that it'll take until November or so to ship ship Amarok, that's kind of the timeline that we're expecting to see at this point. As a final kind of step there, what happens after the token goes live and the DAO gets launched? So I'd like to just take a couple of minutes to sketch out how we think about Connext and why we think the DAO and the token are actually important. Naturally, there is, the DAO is a mechanism for us to decentralize the ownership of Connext itself, the next token, and decentralize how the next token is allocated, and have organic community participation in the decision making that goes into the protocol itself. However, our philosophy around Connext is also slightly different than a lot of other protocol DAOs. So one of the key things on our side is that we strongly believe that Connext is public infrastructure. A lot of DeFi applications and other kinds of token-based organizations run as basically companies, right? It's like a company. There's a centralized company team. They have a DAO that is used for decision making, but then really it's basically run like a corporation. The DAO tries to generate revenue. There are teams internally and decision makers internally, and it functions basically just like an online company that isn't necessarily registered anywhere. Our goal is not to build that kind of organization. We want to build an ecosystem. We want to build public infrastructure in the same way that the internet is public infrastructure. There's no core team behind the internet. There are many, many different teams that are individually contributing to building the internet. Some of those teams are for profit. So folks like Google and Cloudflare. And then a lot of the teams are people, just individual researchers and contributors from non-profit organizations, places like Mozilla, the IETF, and the EFF. We want Connext to head in the same direction. So we want to see a world where this is a key part of why the contributor program exists and why we are taking the measured steps towards launching the DAO that we are. We don't want Connext to just be an organization that basically functions as a corporation on chain. We want Connext to be, Connext Labs to be one of many, many different teams that are contributing to the protocol. We want Connext Foundation and the DAO to kind of oversee those teams. But we think that there needs to be a very, very large number of independent contributors in order to make this credibly neutral infrastructure that can be a part of the internet for a very long period of time. That's something that's been our primary focus with the token. And so delays around the token, the work that we're doing around the contributor program, the measured approach that we're taking to launching the token and to kind of getting this DAO live are all center around this core thesis that we want to build this ecosystem that lasts and have it be genuinely an open public, basically an open public good that many different ecosystems are contributing to. Cool. Awesome. So I think as a final thing, so there was a bunch of community questions that we have that we can kind of talk through, and then I believe I can start jumping into them, but I believe anyone else that has any input should also jump in from the team.
Sure.
So first question. Oh, sorry, go ahead.
Oh, I figured if you want to read them off, you can.
Read them off, please.
All right. Thanks. That was exceptionally informative, and I hope everyone else had as great of a time listening to that as I did. So our first question from the community was, what do you think about the future of interoperability in Ethereum via bridges? I mean, are we going to reach the same level of interoperability as Cosmos through projects like Connext?
Yeah, that's a really good question. Yes. I mean, it's not just going to be Connext. I think Cosmos itself is also now going to evolve. So, for example, with what's happening with like mesh security, and then the work that Celestia is doing, I think there is a likelihood that Cosmos in the future, I mean, it will still kind of work the same way. There will be a bunch of different chains that are connected through IBC and communicating with one another. But I think with like shared security and shared data availability in the future to make it easier to run chains. And so Cosmos is kind of like heading in this direction where it has this interoperable ecosystem figured out, and then now they're working on shared security and shared DA. Ethereum and the Ethereum ecosystem are on the opposite end of the spectrum, where they have shared security already with like rollups and things like that, and shared data availability because all those rollups post onto Ethereum, but no interoperability yet. I think it's very, very likely that both ecosystems are going to go in the same direction. I think what's going to happen is, and we're seeing this happen because we're talking to all of these teams about it. Every single team that is building rollups today and building rollup infrastructure, or in general building scalability infrastructure, this is like Polygon, zk-Sync, Arbitrum, Optimism, Starknet. I'm like everyone is going to go in the same direction where they're going to build infrastructure that allows people to build more rollups. So application specific rollups, things like that. They're all going to build their own data availability layers. So this will be like Polygon Avail is announced, Starknet is building one, Arbitrum is building one, etc. And eventually, all the those data availability layers will post to Ethereum, and eventually you'll just have this like ecosystem that is made up of a bunch of Arbitrum chains, a bunch of Optimism chains, a bunch of zk-Sync chains, a bunch of Starknet chains that will all be communicating with one another through like initially with their own DAs and then across DAs as well. This is a big part of what we lean into. Oh, sorry, go ahead.
Oh, sorry. I was just going to say there's going to be a big difference, I think, and that's just going to be in like how homogenous it is to have this interoperability experience. Like in Ethereum, because you have all of these, like it wasn't, a first-class citizen, so you have all of these other companies building all of these other ecosystems, and they're all going to look slightly different. So for companies like ourselves, it's going to be a little bit harder to connect them because there's not going to be a single unified framework that we can use for all of them. Also, we're not going to be the only company. Like Connext, as much as I would like to say, is going to be the standard. I think, there's other really great teams working on similar things. So not only from, like from the ground up, it's just going to be more heterogeneous.
Yeah, and that's actually the main like difference between the Cosmos ecosystem and Ethereum and like the broader ETH ecosystem right now. Is like Cosmos was designed specifically with interoperability in mind. So like Tendermint's consensus model is specifically designed to make it very easy to build light clients. So then that way they could build IBC. Whereas Ethereum is actually the opposite end of the spectrum, where the model is explicitly very difficult to build light clients for. And every chain in the ETH ecosystem is slightly different. And a lot of the security models are slightly different.
For end users, though, they won't see any of that. It'll just be something that really only when you're building infrastructure that does try to address this and create a unified experience across all of these heterogeneous underlying parts that will have to deal with this kind of complexity, which is why modularity.
That's the problem that Connext solves.
Exactly.
Yeah. So Connext will run on top of these rollup bridges. It'll run on top of IBC. It'll run on top of everything that exists.
Perfect.
Cool.
All right. Next question was, what are the competitive advantages of the project? What makes this project secure or more secure? And what's the most similar contender in the market today in terms of scalability, security, features, and adaptability?
Yeah, that's also a very good question. So obviously the bridging space is very crowded, and there's a lot of like confusion around what each project is doing because it's just a new market. I think like it's also the unfortunate nature of this ecosystem, because it's open source and because the incentives are structured the way that they are, is that like it's extraordinarily easy to like just copy things, and like so there's no real like moat that you can build around having like innovation or anything like that. So this is basically why like Arbitrum and Optimism initially had very, very different approaches, but now they both coalesced to basically providing the exact same experience and being the exact same product. I think there is a high likelihood that Connext will head in that direction, where like to just from a usage perspective, or from a I just want to build on top of it and not care about the details perspective, Connext will probably look a lot similar to a lot of the other ecosystems that are out there. It just will, and like those ecosystems will look similar to each other as well, and there's nothing that they can do about it. So what makes this unique? I think what makes projects unique are a couple of things. The first is the core set of values that the project tries to like align with and tries to focus on. So in our case, trust minimization, security is a big part of it. Why do we think that's important? Because there is a segment of the consumer population, segment of like the developer population that like cares about that a lot. And even beyond that, there is that segment is growing really rapidly, given that bridge hacks keep happening, and given that trust minimization is something that matters increasingly more and more, right? So like the more and more people are realizing that it's actually valuable to have like validating bridges that use like zk proofs and things like that, because they're seeing what's happening in the market. I think beyond, so that's one of the like key kind of values that we want to espouse. The other is like the community driven aspect. So we want to build this like public ecosystem. I think most of our competitors are basically building like their Web 2 kind of centralized enterprise organizations, most of our competitors, and we are not. And this is something that's like one of the key ways that we think that we can grow faster and better than other organizations can. And then of course the last thing is just like the culture, right? So what is it that actually drives a lot of people to be a part of Ethereum and to care about the ETH ecosystem versus building on top of other ecosystems? It's not necessarily even the technology or anything anymore, right? Like there are other EVM compatible chains that do more TPS. They may not have as much security, but they still perform better in the specific ways that developers care about. So what is it? Why is it that Ethereum has retained so many developers and so many core contributors? It's because of its culture, right? We and many of the other people that have been building in this space for a long time care about this idea that Ethereum created, which is like we can collaborate to build decentralized infrastructure on the internet that is provably fair, and that both that problem statement and the philosophy that people in the ecosystem have approached it with is really sticky, right? The people that are building in this space and building on top of Ethereum are doing this because they believe in this idea, not just because they want to make a bunch of money. At least some of them. You can tell in the bear markets which ones are which.
All right, perfect. Next question we have up is, can you explain a little about cross-chain NFTs and how they work?
Someone else want to take this one?
Yeah, I think I touched on it a little bit briefly, but it does work very similar to our architecture, the way that Lane described it, where we lock something up on one chain and then you use the bridge mechanism, the whole transport verification layer, to be able to mint representation of that on the other chain. The cool thing about NFTs is you don't need like liquidity pools around that or anything. You just basically have your NFT that is minted by the bridge, and then that becomes your NFT now. So then you just need whatever marketplace, game, whatever you're dealing with to understand that the NFT on the origin chain has now been locked in the bridge. So they need to be looking at the NFT on the other chain. So there's a little bit of tooling on the front end that needs to be done, but other than that, it's quite simple.
Right on. Now, a bit of a touchy one, big one, but definitely one that a lot of people have been asking. How did the Nomad event impact Amarok?
Yeah. So obviously, we'd had a long-standing relationship with the Nomad team, just separately from Connext itself. They're still like very, very high quality builders in the space. And what happened was extraordinarily unfortunate. We were building on top of Nomad as like one of their users, that like basically building this like liquidity infrastructure on top of Nomad and this experience on top of Nomad for developer integrations, and particularly developers of applications that were going to be using like ERC20 tokens. One of the challenges I think like the way that obviously the way that it affected us was the way that it affected a lot of other folks in this ecosystem, which is that router operators on top of Connext that were holding Nomad assets, just because they were on those chains were like now holding assets that were not actually backed by anything. And beyond that, I think the broader ecosystem of users that were like interacting with Connext and like interacting to be able to get to chains like Evmos and Moonbeam and Milkomita ended up in the same situation as users that were on those chains to begin with, where like they were now holding Nomad assets. One thing on our end is we were actually extremely fortunate. Like nothing associated with our direct cooperation with Nomad was actually live on mainnet in any way. So like we were giving users Nomad flavored assets on the chains where like the Nomad assets were the default assets because Nomad was the canonical bridge on those chains. But we weren't actually like, users were not actually directly exposed to like Nomad beyond the bridging activities that they were doing to the chains where that like they would have already had that exposure. So if you're a user and you were bridging to Evmos separately and were like using Evmos separately, you would have still had the same kind of risk exposure. That's something that like we've kind of tried to think about quite a bit, where it's like it's a bit challenging because this is like the unfortunate nature of composability in this space is like whenever you build on top of any infrastructure, you are automatically assuming the risk of that infrastructure. So for example, today, right, if DAI, for some reason, something horrible happens to DAI and like the currency completely depegs, we and pretty much every application in this space is completely fucked. Right? There's not really anything we can do about it. And like while we and many others do like due diligence on protocols that we build on top of, and we definitely did our due diligence on top of Nomad, it's always entirely possible that like some things are missed or some things just are not, that like future bugs can occur as a result of upgrades and things like that. Now the main way that Nomad actually affected us was in terms of our like upgrade itself. So how we could actually build out Amarok. The main change that's happened between the Nomad hack and now is that we've just gone and built our own system that underlies Connext and basically leverages other systems for messaging. So we kind of kept the same interface. We still like really like the Nomad model, so we're still like using the optimistic verification mechanism that they proposed. But in addition to that, we're also like leveraging existing bridges as much as possible.
Perfect. So a couple other questions. What are some examples of xApps that could be built on the Amarok platform?
Again, I think we've gone through a bunch of these, but basically, yeah, maybe the person who asked the question was watching and saw all the slides, but we did fill a lot of these out. But basically anything that is currently in DeFi right now can be basically transitioned over, as well as there are applications that are probably like cross-chain native. Yeah, I mean, one cool thing to say about this is that I don't think we've really like unlocked the full level of use cases that is possible with cross-chain.
Apparently the live ended at 4 exactly.
Oh, sad.
At 4? Oh, you're using your time. Top of the hour. Okay.
Okay, so I guess should we continue answering the question, or
we're
no?
still recording on the back end, so it can be a treat
Oh,
when
nice.
we upload it later.
Yeah, level alpha.
Well, the alpha I was going to link was it's cool to have. I mean, one cool thing that you could do is you could try to think about these things, how you link up like a storage mechanism like Arweave to like another chain. So you could basically like have separate execution layer and data layer, and you could have like really cool interoperability between them and create these cool applications with decentralized storage.
Right on.
Yeah. So just to like touch on that a little bit. So like this is something that we've been like I've been talking about internally a little bit, and like started to talk about on streams, and I think the idea is starting to catch on because I think it's actually very, very important. I'll try to write a blog post on it next week. But I think like one of the reasons that I personally became interested in this space is this whole idea of like a decentralized world computer. Right? You have this like decentralized, instead of having like a server somewhere that you're running code on, you have this world computer that just like does it's just a computer that runs the entire world's operations. But that that was like kind of the original vision for Ethereum, and it didn't end up really panning out because Ethereum is just too expensive to use for that in that way. Like Ethereum can't be used to do like generalized compute right now. You can't run a machine learning model on top of Ethereum. You can't like host like fully public APIs on top of Ethereum that have arbitrary data behind them. But you can build from Ethereum, from like, I guess a roll up is probably best, but maybe something like Arbitrum, you can build a connection directly from an Arbitrum smart contract to Arweave through Connext. And you can also build a connection directly from an Arbitrum smart contract to Golem network and to other kinds of resource networks for compute, for GPU like usage, for storage, etc. And what that allows you to do is actually build like a old school von Neumann computer, right? And basically, like the basic idea of a computer is just a system that has like compute, a message bus, and storage, and that's a rollup, Connext, and Arweave. This is super powerful because it actually allows you to do really, really interesting things. Like you can imagine in a theoretical end state in a world where like you have Wikipedia running on top of Arbitrum or Starknet. It stores all of its data on Arweave, and the connections between sources and the editing and like adjudication of the system happens on chain. You can have a machine learning model. You can actually have like DALL-E 2 or Midjourney live on top of Ethereum as like fully unstoppable public AI. I think that's actually that's like next level stuff that will unlock probably the next iteration of what the internet can actually make possible that we haven't even begun to think about right now. And that's something that, at least to me, like, of course, there's like, it's very exciting to have cross-chain DeFi applications, very exciting to do cross-chain NFTs, but those are like taking an existing thing and then making it cross-chain. Whereas I think what we're talking about here will be an entirely new set of use cases that have never, ever been possible before.
Awesome. Next question is, and also thank you for rejoining us for anyone that was dropped there. We had a hard stop at 1 hour, but we have relaunched. Everything is currently being recorded, and we will be publishing that recording later on. The next question coming up is cross-chain arbitraging easier with Connext?
I think cross-chain arb can be difficult, but anything that makes it faster to go across chains will make cross-chain arb easier. I think the core problem with cross-chain arb is just that you're generally going to be competing against people who already have funds on that chain. So if you depending on the path between the chains, so if I'm going from like some chain with a really, really fast block time to something with a slower block time, that general slowdown from going cross-chain won't be as impactful. But yeah, anything faster, which Connext is faster this time than our previous version, will be a benefit to cross-chain arb.
On this note, we did talk to a bunch of arbors for a while because we weren't interested in this use case. But yeah, like, mainly everything we got from talking to them was saying that it's not worth it to compete with people who already are on both chains, because the real cross-chain arbors are sitting there with tons of funds on every chain.
Makes sense. Next question we have, are there any plans to connect with non-EVM chains like Polkadot or Cosmos, or parallel execution chains like Aptos or Sui?
Yeah, we would definitely love to. It's certainly like, I couldn't give you any dates on it, but it's definitely something that we've kept in mind as we've developed this architecture.
Yeah, this is like basically our philosophy around this is like we as a core team want, or like as the founding team want to focus on like the Ethereum specific implementation, just because like we haven't built expertise in building applications for other non-EVM chains yet. However, we are already talking to teams externally for like outsourcing integrations into other ecosystems. There's already like in progress work for one ecosystem, and then early conversations for others as well. Like basically it involves porting Connext over to those, like porting the Connext contracts and system over to like whatever, like Cairo for Starknet, Rust for Solana, etc. And then finding some like canonical bridge that we can use to get to that ecosystem that we can then build on top of. So for example, like a Rolla bridge for Starknet, Wormhole for Solana, etc.
Great. And then last question, because we're finally at the end. And again, I want to thank everyone for joining us here today. What is the biggest strength of Connext compared to so many other bridges?
I mean, I think if you really want to talk about the biggest strength, then you have to think about, where you're going to be able to find competitive advantages. And because everything's open source and you can pretty much fork away most advantages from innovation. But what the team is really good at, as hopefully was conveyed during the brief history of the team here at Connext, is staying agile within a constantly changing ecosystem. That's something that's just kind of in our DNA. We're not deeply attached to any ideas that we've had in the past, and we're like always looking to improve on that front. And I think that's kind of really not only an important competitive advantage for this team, but really the only important competitive advantage within the industry, or like special thing within the industry, just because it moves so fast.
Yeah, I mean, I think beyond that, like, of course, like bridges themselves as a core concept. I mean, and I'm referring to specifically as like bridge UIs here, which is what I assume that the question is referring to. Bridge UIs themselves are sort of like they exist right now because there is this like key need that nobody really had a better way to solve, but they are themselves going to disappear. I mean, I think like we're not interested in winning the bridge UI space. Like that's never been our focus. We are not going to win it. We're not UI builders, and we don't want to be. Like our focus is the competitive advantage for us, and the way that we actually win this ecosystem is by building something that helps other people succeed, and that helps like other infrastructure projects and other kinds of applications succeed, and then building a community around that. And I think that's something that we've been able to do a lot better than anybody else has so far.
Completely agree. All right. Well, thank you for joining us today. I hope that everyone found this exceptionally informative. I know I did. And hopefully we'll do another one of these again soon. If anyone has any final words, feel free to share those with the group. Otherwise, I hope everyone has a lovely morning, afternoon, or evening, no matter where you are.
So thank you all so much for joining. Really appreciate it.
Thanks, everyone.
Bye-bye.
Bye all.